Every long-running agent has a hidden tax, the context window tax. You ask one agent to scrape docs, inspect files, pull database rows, reason about all of it, and write the answer. At first it feels powerful. 2 loops later the chat history is swollen with raw HTML, SQL tables, failed tool logs, and duplicate snippets. The model is not getting smarter. It is dragging a heavier backpack every step. Today we fix that with smolagents, the managed agents pattern, and native MCP. Watch the penalty in a monoagent design. The user asks a clean question, which API changed in the docs? The agent fetches 3 documentation pages, dumps every section into the main memory, then asks a database tool for recent usage rows. Now the orchestrator history contains navigation text, footers, cookie banners, full tables, and irrelevant columns. The next reasoning step has to reread all of it. Latency climbs, token cost climbs, and attention gets diluted before the final answer even starts. This is where hallucinated arguments appear. The model saw 20 similar function names, 2 old examples, and a table column called status that had nothing to do with the API status parameter. On the next tool call it invents a stale argument, include _archived equals true. That argument never existed in the current SDK. The bug looks like reasoning failure, but the root cause is memory pollution. You asked one brain to be scraper, analyst, database reader, and final presenter. 4 beats in 12 minutes. First, we name the context tax. Second, we isolate messy work with a managed child agent. Third, we connect an MCP server directly inside smolagents over stdio. Fourth, we audit the tokens side by side and prove why delegation keeps the orchestrator sharp. Keep the timeline visible, the live code starts at 5:30, and the proof lands at 10:30. The managed agent pattern is the escape hatch. Instead of giving the orchestrator every raw document, you create a specialized child code agent with a name and description, then pass it into the manager through managed_agents. The child can browse, scrape, search, parse, retry, and make a mess inside its own memory. The parent receives one refined artifact, a short, high-signal summary with citations, constraints, and the answer-ready facts. Same model family if you want. Same tools if you want. Different memory ecosystem. That is the whole trick. Architecture view, the orchestrator stays clean. It owns the user goal, the plan, and the final decision. The research child owns noisy retrieval. It can hold a full docs page, a failed scrape, 5 search results, and a local file listing without poisoning the parent. When the child returns, the transcript boundary compresses thousands of tokens into a few hundred. This is not only cheaper. It changes behavior. The parent no longer argues with stale snippets because stale snippets never enter its memory. Think of it like a senior engineer asking an intern for findings, not every browser tab they opened. The parent cares about conclusions, evidence, and risks. The contract matters. Do not ask the child to send back everything it found. Ask for a structured brief, answer, evidence, caveats, and exact commands or code symbols. If the docs are uncertain, say uncertain. If 2 versions conflict, name both versions. The child agent can spend tokens freely inside the sandbox of its own run, but the return payload must be curated. The managed agent pattern turns raw context into a memory firewall. The parent sees conclusions, not debris. This is where most teams fail. They delegate retrieval, then paste the dump back into the main chat. That defeats the whole pattern. Now the orchestrator loop is simple. Step 1, delegate noisy retrieval. Step 2, receive the brief. Step 3, decide or call a second specialist. Step 4, final answer. Notice what disappeared. No giant scraped page in the main conversation. No database table pasted into the same memory that writes the final response. No accidental prompt injection from a docs footer writing along for the next 10 turns. The parent remains a strategist, not a landfill. You can add more specialists later: docs, database, browser, logs. The rule stays the same: private raw work in, curated brief out. This gives you scale without turning the parent prompt into a junk drawer. Live code starts here. We are going to connect a real MCP server directly from smolagents. No adapter class. No custom wrapper around every tool. MCP already exposes tools with names, descriptions, and schemas. Smolagents can consume that tool list through MCP client. For the demo, use a stdio server, Brave Search if you want live web results, or a local file system MCP server when you need deterministic recording. The connection pattern is the same. I prefer file system for recording because the output is stable. Then I mention Brave Search as the network version of the exact same idea. Show the command first, then the Python file. That helps viewers separate server startup from agent wiring cleanly. The server is just a tool provider, the child agent is the memory boundary. Here is the current safer code shape. Import code agent, inference client model, and MCP client. Create MCP client as a context manager with command, args, and transport equals stio. The context manager yields the MCP tools and handles cleanup when the run is done. Hand those tools to a child code agent. The child needs a name, a description, and provide _run_ summary equals true. Name, description, and run summary make the child useful to the manager. Then create the orchestrator with managed _agents equals researcher. Read the indentation carefully. The orchestrator lives inside the with block, so the MCP subprocess exists only during the agent run. Notice what we did not write: no Brave adapter, no file system adapter, no manually mirrored JSON schemas. MCP provides the tool surface, smolagents turns it into agent-usable tools. Keep the client lifetime explicit, open it before the run, close it after the run. The child is just a named code agent, not a separate wrapper class. Run it with verbosity on. The terminal should show the MCP server booting over stdio, tool discovery completing, and the child agent receiving tools like search, read_file, or list_directory. The parent does not call those tools directly. It decides the task needs research, calls docs_researcher, and waits for the brief. Inside the child run, raw pages and tool outputs can be huge. That is fine. They die at the child boundary unless the child summarizes them. Count the memory boundaries: parent step, child step, MCP tool call, child summary, parent final. That visual count makes the abstraction obvious. Also show the negative space: no parser for a search response, no handwritten class for each MCP tool. The server publishes metadata, MCP client reads it, and the child agent sees normal callable tools. Now query it. Ask, read the latest MCP docs and tell me the exact stdio setup shape and smolagents. The child searches, reads, rejects stale examples, and returns a compact brief. Use MCP client as a context manager, pass the yielded tools into a named code agent, then place the child in managed _agents. The parent receives only the brief, not raw files. Show the contrast: raw MCP output in the child trace, refined summary in the parent trace. That is memory isolation. Point to the summary keys: answer, evidence, caveat, code shape. The audience needs the boundary, not the crawl. Keep this beat brisk and visual. Then move quickly to the token audit, because the next slide proves why this boundary matters. Token audit time. Same task, same baseline, 2 traces. Monoagent trace, prompt plus history, docs pages, search output, database rows, and failed call logs. The final loop hits about 28,000 tokens. Delegated trace, parent prompt, user goal, child call, and a 600 token research brief. The child spent tokens, yes, but the parent never rereads the mess. The math is the proof. Suppose raw retrieval is 8,000 tokens and the task needs 4 parent reasoning loops. Monoagent pays 8,000 times 4, 32,000 repeated input tokens. The managed agent pattern pays 8,000 once inside the child, then 600 times 4 in the parent. That is 10,400 tokens. Truth stays, replay disappears. Use this rule. Delegate whenever a step creates bulky, temporary context, docs, folders, tables, logs, or many files. Keep small, stable, central facts in the parent. Managed agents are not ceremony. They are memory isolation when raw context would dominate reasoning. The pattern is simple: parent plans, child researches, MCP connects tools, summary crosses the boundary. That beats the context tax without weaker tools. Comment SMOL for the companion code, and use this before your next agent drowns in history. Allah Hafiz.